Hey, hello everyone. Today we are going to solve this daily challenge from LeetCode, all possible full binary trees. So we are given an integer n and we have to return a list of all possible full binary trees with the given number of nodes. So the value of each node should be 0. And what is a full binary tree? It is a tree where each node has exactly 0 or 2 children. So anything having only a left node or a right node is not a full binary tree. So seeing this, we can say that this is possible only for odd numbers. So suppose, for consider this part 3, so there will always be one head, and then we will need either 2 children or 0 children. So it will always sum up to an even number adding with a 1, so that will be a odd number. So full binary tree will be only possible for the numbers that are odd. So for even, we will return empty list. Now for odd, we can break down this problem into smaller subproblems. So we can start by making all the binary trees having one node. Then we can go on to form all the trees having 3 nodes, then 5 nodes, and then finally 7 nodes. So you can see that we are increasing the numbers in by 2. So basically we are solving only for odd numbers, since I already told that even trees are not possible. Now suppose I am at this node. I have been asked to make all the trees of size 5. So I'll have a head node, and then there will be like 3 possibilities, or I think say we can keep one node this side and 3 remains, so 3 will be here. Then we cannot take 2 this side because that is not full binary tree. Then we can take 3 this side and 1 this side. So these are the only 2 possible trees with the size 5. Then we have 7. So we keep a head node, then we have 1 on this side and 5 on this side. Then all both the possible variations of the size 5. Now we will have 3 this side and 3 this side. So what you can see is that we have to keep all the possible combinations of the numbers, like the number of the size of the tree minus 1, and iterate it from 1 to that number on the left side, and the remaining size would be attached to the right side, and we have to attach all the possible trees of that size to that side. Now for that, we will have to keep storing all the possible trees that are possible for that size. So we need to store both these trees of size 5 so that they can be reused whenever required. Because like I'm attaching it to the right side first, and then I'm attaching it to the left side at the last. So this means it is being reused, and we need to memorize this. So 3 things we've got: that only odd numbers will give us a full tree. Then we can start by making trees of small sizes, start from 1, 3, 5, 7, and we will go on in that way by adding on 2. And finally we will keep on storing all the possible trees in arrays of that size and make use of them to implement DP and memorization. So first of all, if the size is odd, so even, we will return an empty list because it is not possible. Now let's move on to declare the DP vector to store the trees. So vector and tree node. So I'm naming this nodes, and there would be n plus 1 trees. N plus 1 sizes means from 0 to n, and we will just initialize the first one, the tree with the size 1. That there is only one possible, and it would be a single node itself. So nodes 1 of size 1 will have only one possible tree, and that is a single node. So we will just define a new tree node of value 0. Now what? Now we will start to iterate from 3 because we have already stored 1 and we do not need to check 2, and I should be less than equal to n. Obviously we have to go till the size asked, and we will keep on increasing it by 2. So we have to check only odd numbers. Now once I'm so basically this is size I is equal to the size of the tree. Okay, now what? Now I need to define the size of the left child. So j will be size of the left child, and what will be size of the right child? It would be size of the right child will be, so there are, say, suppose three nodes, so we can have either one on the left side, or we can only have one on that side, because one will already be acquired by the head itself, so we are remaining with two. So what I'm trying to say here is we have total nodes I, then we have given one to the root node, and the remaining we have given j nodes to the left side, so the remaining go to the right side. So just for uniformity, let me write this in this manner. Now, so I'll have to iterate int j equal to from 1, and this will not go greater than or equal to the outer loop, the total number of nodes minus 1. So yes, it will go up till 2 only, and then we have j equal to 2. So any child node attached to a root node should itself be a full binary tree, so it will also have odd number of children. So here, therefore, I am increasing it by 2. So this will, for I equal to 3, this will only run once, because 1 is here, and there is only one possible formation of this tree, and that is this thing: one head and one left, one right. Now, once we are inside this loop, what we need to do is we will see how many possible trees are there for the size of the left child. So we will just iterate auto left nodes in. So we will have already stored all the possible trees having the size j, and for each of them there will be a corresponding right node as well, and whose size will be I minus j minus 1. So this will take care of all the possibilities. It's just like we are calculating a probability, or just multiplying to make it to calculate all the possibilities. So now we just need to declare a new node, because we have to keep pushing in the possible trees. So tree node tmp is equal to new tree node whose default value will be 0, whose left node will be left node, and right node. So I'm writing it in this manner by using this definition given here by default. So I can just pass the left and right nodes into the parameter, and it will already by default make it its left and right tree. So I just change the name here. Okay, now this tree is complete of size I, so we just push back it into our vector nodes of I. So basically nodes I is the array storing all the possible trees of size I. So nodes back, and it will store the tmp. Now you can see that by the use of these 4 loops we have taken care of all the possibilities, and we just need to return finally the list having the size n. Let's run it. It gets accepted, and we will submit it. So so this is fast enough, and it is consuming very less memory also. So instead of going with this loop, you can also go from top bottom. So this is bottom to top approach, where I am going from I equal to 3 to n. We can go from n to 3 also by making use of recursion. So we will call this function again and again, and every time we are inside this loop here, I will just call the function, call this function with n equal to j and n equal to I minus 1 minus j, and I will get both the lists, nodes j and nodes I minus j minus 1 list, and then I can do the same thing here. So this was all. Hope you liked the solution, and see you tomorrow.